All right, so welcome. So we're going to talk about scalable automatic machine learning in H2O open source machine learning libraries. So this is the same kind of tool as driverless. So the goal is to do automated machine learning, but we're using entirely the H2O ecosystem, which is CPU-based, where driverless is primarily focused on GPUs. So, all right, so first I just want to introduce you to the AutoML team. So I think they're probably both here in the audience, but it's myself, Sebastian, and Andre. So we do have some former team members. So Navdeep Gill used to work on AutoML and contributed quite a bit, and another guy named Ray before that. But this is the current team, and so if you see these guys, say hello. Okay, so I'm just going to explain a little bit about what is automatic machine learning, because it's kind of a generic or ill-defined term. So I'm going to give you sort of my definition of what I think it could include. So it could basically include anything that you would do as a data scientist in sort of automating that process. So that might include some aspects of data preparation. So I'll go into a little bit more detail on the next slide about what each of these mean. And then we could also, probably you're going to end up generating a lot of models and then either selecting from those models whatever the best model is, or the third point, which is sort of optional but can help quite a bit, is to create ensembles of those individual models to get optimal performance. So, and if you're new to the whole AutoML concept, there's a blog post that I wrote, I guess in August, that explains the term AutoML, because there's, I think we were the first tool that used the word AutoML, but there's other ones now that, like Google has a tool that they call AutoML. I think all the big tech companies are now trying to do an AutoML. So, and they're all very different tools, and they have different use cases. So if you're unclear about which tool might be good for you, you can read this blog post, and it should kind of lead you in the path of whatever particular tool. Okay, so let's talk a little bit more about what these things mean. So in terms of data preprocessing, that could be some simple things such as just dealing with missing values or categorical values in your data. So processing those in a way that a machine learning algorithm can understand. And then once you've done that, you could do maybe feature selection or feature extraction. That's once you've set your data set, then either reducing that or appending some extract features or reducing noise features. And then probably the most valuable of this list here is doing different types of encoding for categorical data. So this is very important, especially if you have high cardinality categoricals. So an example I like to use is like a zip code. If that's one of your columns, there's some sort of I guess zip code, I'm not in the US, but I assume postal code is what you have here. So, in the US, there's maybe like 50,000 of these codes, and they are numeric, but they're actually representing categories. And so if you have 50,000 different levels of your, categorical feature, that can be kind of a problem for a lot of machine learning algorithms. So different ways to handle these, real world data problems in a graceful way. So then in the model generation section, there's lots of different ways that you could generate models. The most straightforward way would be just doing some sort of grid search, either a random grid search or a Cartesian grid search, which is regular grid search basically. You could use other techniques like something called Bayesian hyperparameter optimization, where you successively get closer to a good model as you learn more information about how each set of hyperparameters does, and you actually use another model on the side to help you learn the mapping between the feature or the hyperparameter values and the performance of the model. So that's another approach. And then just individually tuning the models if you have a validation set, like if you, for example, are using a GBM, you don't want to overfit the GBM, so you might initially tell the GBM it could use up to, say, like 10,000 trees, but then you want to stop somewhere before that so you don't overfit. So that's what I mean by model generation. And then ensembles, there's different types of ensembling. Here, these are just two common ones. Stacking or stacked ensembles, also sometimes called superlearning. It's the same thing. This is a technique of using a machine learning algorithm to learn what the best combination of the models are. So you give it a set of, let's say, 10 or 100 models or something like this, all different types like GBMs, random forest, deep learning, GLMs, whatever it is. And they don't all have to be great models. They just have to, it's good to have sort of a diverse set of models, and then you perform what's sort of generically called meta-learning, but that term can apply to other things as well. But basically, it's just learning how to best combine those to predict the outcome. And then there's another type of ensembles that I'll just mention called ensemble selection, but I won't go into detail about that. And then this is the same slide, but I've highlighted what we have right now in H2O AutoML. So on the data preprocessing side, we're doing just right now the basic stuff that you get in all the H2O models. So there's nothing extra there, but one thing that I'll mention at the very end, I'll show you the H2O3 roadmap and some of the new features that we have. One of the things that we've recently added, actually Andre, who's on the AutoML team, added the basically target encoding to H2O3, which is a big improvement, and so that will handle these sort of messy cases of high cardinality categorical columns like a zip code or a postal code, or even, it doesn't have to be high cardinality, just proper, like, good handling of categorical features. That's not in AutoML yet because we just put it in H2O, but it will be in AutoML on the next release. And that will help quite a bit. So this is a good time to point out, this is one of the differences between driverless and AutoML. So people often ask, what are some of the differences? There are a lot of differences, but one of, if you're sort of a data scientist, one of the things that you'll notice is in driverless, you're getting all sorts of automatic feature engineering. And in AutoML, you're sort of either expected to do that yourself or have some existing tool to do that. So that's sort of just something to point out. And we use a random grid search over all the different algorithms that we have in H2O. And I mean, it's not completely random, so we've set specifically which parameters we should grid over using our own expertise and expert knowledge, and then defining what those ranges for each of the parameters is. So that's one of the harder parts about data science, is just being familiar enough with all the different algorithms to understand all the parameters and all the ranges that are good that you might want to look at. I mean, you could just do a grid search of everything that exists and every possible range, but then you just have a very expensive EC2 bill, basically. So, and the reason that we like random grid search is because what that does is it generates a diverse set of base models that can be used in the stacked ensemble. So it's kind of these two things that work really well together. And even if we get models that are complete garbage, basically, because they're just randomly chosen and maybe some of them are bad, the stacked ensemble will learn to ignore models that are not good. So let's see here. Okay, so now, so AutoML is in H2O, so it's in all of the interfaces for H2O. So one of the interfaces that we have is the Flow GUI. So, I don't know exactly what percentage of our population is using Flow versus R, Python, but we have a significant number of users of Flow. So I'm showing you this as well because it shows all the parameters that are available in AutoML. So some things that you can do. So basically, I'll show you on the next two slides the R and Python interface. You really only have to set one or two parameters to AutoML. You basically have to say, what is your data set? What are you trying to predict? And how long do you want to run this thing for? So this is just a little bit more verbose because you see all the other things that you can choose. So, one of the things you'll see there is you can exclude different algorithms. If you know in advance that maybe you don't want some of the algorithms that we offer, you can get rid of them. Let's see, there's different things that have to do with early stopping. So if, these are things that you can tweak. So one thing we like to do is have the most simple interface that we can imagine, but also provide access to all the different underlying knobs that you might want to tweak if you're an expert data scientist. So we see this as a tool for a wide variety of people. So this is what it looks like in R. Basically the same interface as all the other H2O modeling algorithms. We have training frame, so that's your training data. Y would just be the name of the column for your response or your outcome, the thing that you're trying to predict. And then in this case, we're just saying, I want to run this for 10 minutes and then stop. So you can control how long the AutoML process will run either by time or by the number of models. So, it's sort of preference thing, whatever works best for you. Maybe you want to just start with 20 models or 50 models and then do it that way. And maybe you don't know in advance how long the models are going to take, so you don't want to use time. And then here's what it looks like in Python. So same exact set of arguments, basically. So we like to, when possible, use the same names between the Python and R interface, so it makes it easier for documentation and just easier for people to use. So in this case, it's a little bit more Pythonic, where you have a object of class H2O AutoML, and you set the parameters for that object like so max runtime seconds, and then you do call the train method pointing to some data set that you want to train on. So same idea. And then what you get back is what we call the leaderboard. So if you're familiar with competitive data science, or Kaggle, they use the term leaderboard. And that's a place where after we've trained all the models, we rank them by some metric. So this is an example of, so this is a real example of a data set that we have in our user guide. So if you go to the AutoML user guide page, this will be the output for the leaderboard there. So you could try this out on your own. So basically, some things to notice here. So this is an example for a binary classification task. So that would mean that we have different metrics for this leaderboard. So these are the metrics that have, that are useful for binary classification. So AUC, log loss, mean per class error, RMSE, MSE. So, if you don't tell AutoML which one of these you care about, we will just choose for you. So the default metric for binary classification, if you don't tell us otherwise, would be AUC. So what you're seeing here is the cross-validated AUC. So this is by default. Of course, you can change this as 5-fold cross-validated AUC on the training set that you gave AutoML. So, and you can also choose to not do cross-validation. So if you wanted to, get more work done quickly because you're not training 5 models instead of 1, you could pass along just a separate training frame to score the leaderboard. So in the set of arguments, we call that leaderboard frame. So, but one thing, the reason that we do cross-validation is, one, it's good to give you a good estimate of performance, but also because it's part of the stacked ensemble process. So what the stacked ensemble model does is it trains a model on the cross-validated predictions of the base models. And there's other longer presentations where you can learn a lot more about stacking and how all of that works if you're interested. So just look either on our, where we keep our slides online, or YouTube, basically. So, so then what else I'll point out here is, so what you see is a list of model IDs. So those are just generated automatically. So at the top, we have stacked ensemble. Yeah, question? Oh, 4 minutes, okay. So we have stacked ensemble underscore all models. So what that is a stacked ensemble using all the other models that you've trained in the process. And that generally is the top model. So because it has the most information and it's doing the most advanced modeling. And then, it's not always the case, but then the second one is often what we call the best of family stacked ensemble. That's another stacked ensemble, but it only has a few models in it. So it only has a model from each of the different types of models that we have. So we just take the best GBM, the best random forest, et cetera, et cetera. So it's a lightweight stacked ensemble. So if you want to go to production with a stacked ensemble, you might choose to use that one instead. It's be quicker to do the predictions. And so, if you had 300 models in your AutoML, you'd have a 300 model ensemble, and maybe that's not something that you want to put in production. Or if you don't care about speed, then you can. So then what you see next would be some XGBoost models. So this is brand new in the newest version of H2O, H2O 3.22, which just came out a few days ago. So Sebastian, who is the other person on the AutoML team, he has integrated XGBoost into AutoML now. So that's a new thing, and we're seeing good results with that. So you see on this example, the top 5 or so models are all XGBoost models, followed by H2O GBM models, and this leaderboard is actually longer. I just cut it off, but then you see a random forest and some deep learning models below, and yeah. So let me skip ahead. I think I'll skip this part. This is just some pro tips on using AutoML. I've mentioned some of these things, but you can refer back to this slide once you get started on AutoML. I just want to make sure we have time for questions. And then I just also wanted to mention the H2O 3 roadmap. So a lot of the work is driven by what we hear from you guys, so either the community or our customers directly. So this is how we determine our roadmap. And so some of the recent stuff that we've worked on is we've really spent a lot of time getting XGBoost to be very stable. And we've done Mojo and Pojo support for AutoML. We first started with target encoding in R. Now we have it in Java, so it's available in Python as well. We added XGBoost to AutoML. There's a couple new algorithms, so isolation forest algorithm. We have more DevOps things like native Hive connector, and something happening in the future is we'll add custom loss functions for GBM and random forest. So if you're a business and you have some metric that has a direct link to your costs or profits or something like that, you could put that inside of GBM so it's directly optimizing that. And then time series cross-validation, that's another big one. And once we have that, we can do more advanced type of stacked ensembles as well. Oops, I'll leave that up here, and I just want to see if there's any questions.
Yep, so there's a few questions. Let me pass this up to you.
Okay. All right.
Oh, and while she's reading the questions, one of the questions, somebody made a comment that I guess someone found a debit card. So if someone lost the debit card, maybe afterwards you can stick around and we'll get it to you or come up to the front and in between. So.
Okay, so the first one is, does AutoML run on GPUs? So yes and no. So basically, the XGBoost algorithm has GPU support. So when it's using XGBoost, you can run it on GPUs. But for the other algorithms, they only run on CPUs. So you can combine, both together and still make use of a GPU if you have one. And then I'll just do one more question, which is, there's two different questions asking about stacking in AutoML versus driverless. We're both doing stacked ensembles, so essentially, yes, we're doing the same thing. We're doing the meta learning step a little bit differently, so there's some little bit of difference, but essentially same concept overall. And then someone also says there's a debit card found in this room. Mr. Amid Abbasi Benny, can you call this out after the session, please? So, that's another one. Okay, so I think that's it. So we'll just wrap that up. All right, so also there's AutoML stickers now. Go find them out there. They're beautiful and